welcome to the 7th episode of Printing Case Sharing. The subject we are about to discuss is very functional and very popular in the industry, which is the technology and application of microfluidic channel. I think most people are not familiar with this subject, but microfluidic channel is a very practical subject in our daily life. Probably just didn't notice. Like lots of famous technology wafer factories in Taiwan, they combine the most common technology, semiconductor electronics industry process, and MEMS, which stands for microelectromechanical systems, coordinates with semiconductor production procedure, is useful for wafer fabrication. Not only the microfluidic channel could be used in physical chemistry, but also in medicine.
Next, let's take a further step to know more about this technology and what advantage could 3D printing bring to apply with this technology. That is the subject of this episode. Let's get started. We can divide the subject into 4 categories, which are microfluidic technology introduction, case introduction, analyzing the case, and printing video. In microfluidic technology introduction, there are 5 topics we can discuss. First, what is microfluidic technology? Second, what object or device uses this technology? Third, what advantage does microfluidic technology have? Fourth, why does the laboratory need it? And the last one, the new research and discovery of microfluidic chips. The microfluidic technology refers to control, operate, and detect complex fluid in microscopic size. If you use this technology in biochemical, it can reduce the volume of fluidic of biological and chemical reactions. Imagine putting all the things a laboratory can do in a tiny microfluidic chip. That's how fascinating microfluidic is. It's an interdisciplinary technology based on microelectronics, micromechanics, bioengineering, and nanotechnology. It's a technology precisely controls and operates microscale fluids. And next, what object or device will use this technology? Microchannels have a wide range of applications, including microfluidics, heat exchangers, chemical reactors, and biomedical devices. In microfluidics, microchannels are used to control the flow of fluids at the microscale, which is important for many applications, such as lab-on-a-chip devices and microreactors. The history of microfluidics could go back to 1980s and 1990s. It combines semiconductor, optoelectronic, and materials, and the invention of micropump, microvalve, and micromixer, especially the invention of plastic material, PDMS, from the early 2000s. Because it is easy and affordable. Therefore, the application in biomedical field shines brilliantly. Many researchers want to put biochemical reactions in microfluidic chips due to its convenience and high yield. It could also decrease the reagent volume. It is a convenient and affordable technology for many laboratories. Next, we're going to discuss what advantage does microfluidics technology have, why does the laboratory need it, and the new research and discovery of microfluidic chips. Microfluidic technology is to operate and analyze fluid in microscopic size. It has an advantage like miniaturization, high efficiency, and low cost. For example, in the diagnosis of lung disease, respiratory samples can be analyzed for bacteria and viruses through microfluidic channels, thereby helping doctors for giving accurate diagnosis and treatment. Furthermore, microfluidic technology could also apply to the research and development of drug delivery systems, improve drug delivery efficiency, and reduce side effects. Next, biology. It could be used in single-cell manipulation, cell culture, and drug screening. It could achieve high efficiency and accurate chemical reaction. It could also be used to research the physical phenomenon in microcosm. For example, capillarity and fluid mechanics. The advantages of microfluidic are that they reduce reaction volume, reduce cost, and operate reagents for small flows and solutions precisely. With microfluidic, the possibility is limitless. Next, case introduction. As you can see from the sectional view, the structure design of microfluidic is special and complicated. Just like the color of the arrow, it means the direction of the fluid is staggered. The complexity increases the difficulty in printing. Next, introduce the types of microfluidic. As you can see from the 4 sectional view above, there are many types of microfluidic. Our equipment is able to print all of these types, even the complicated structure like this. Our equipment is able to accomplish high precision and complicated design microfluidic. Next, case study. We will analyze the case. We need some parameters or specifications in order to print those complex models, just like the picture above. How the object is placed, because the contour needs to stay clear. Therefore, the placement of the object is based on its stackability. Let me elaborate. We can use the method on the left to print, because that method couldn't use support material. The placement could cause the middle part to collapse. If we use the method on the right, we could utilize the stackability of silicone to print without support material. Our silicone is specially designed for our equipment. It would be hard to picture if we just show you the chart. Therefore, we add another video of what will happen if we use the left method to print. Does the middle part really collapse? What does that look like? We will do a little experiment to demonstrate. Back to the right method. Let me zoom in for you. The minimum size of the conduit is 0.6 millimeters. The minimum thickness of the clapboard is 0.5 millimeters. Silicone is liquid. Therefore, if the conduit is less than 0.6 millimeter, the conduit will disappear due to the verticality. If the clapboard is less than 0.5 millimeters, the object will collapse due to lack of support. The attached picture is the detailed setting of printing parameters. This setting page is in our manufacturer software. This case is more precise and complicated, so we use 0.25 nozzle to print. Meanwhile, we intentionally set the speed a little bit slower to make the accuracy performance better. You can use the software to stimulate the process, so we can be aware of what situations might happen and adjust the perfect parameter. For the final part is the printing video. We're going to show you the actual process and what will happen if we use the wrong method. We will do a little experimental video to compare the results of using 2 different placements. The above is the theme of our microchannel printing case. Thank you everyone for watching. If you like our channel, please click the thumbs up, subscribe, and share. And don't forget to click the bell for our latest updates. Thank you everyone for your support. We will continue to work hard in the spirit of giving back. Your support is the power to let us keep making more quality video. If you have any questions, leave a comment down below. Or if you want further information, please feel free to contact us. Don't forget to follow our major social platforms and subscribe to our YouTube channel. That is the end of today's video. See you next time. Bye bye.